It's almost similar to previous, but small modification is there. Let's see how many people will do that. The challenge is given an undirected graph. Given an undirected graph. Given an undirected graph. The task is to check if there is a cycle in the given graph. Previously directed graph, now it is an undirected graph. In the given undirected graph, how to check cycle exists or not? Almost similar because of lack of direction. Some problems are coming. Can you please do this? Try honestly. Small doubt also they ask in the comment section. It is going to be one of the excellent problem. Using DFT you can do. Using DFT also because of same time. You no need to bother that much. DFT is going to be much easier than the BFT. You can go ahead this. It's one of the famous problem of computer science. Like previous problem, this also, can you try this? This problem also can be solved like DFT. Right? Using the previous one. Means DFT algorithm can solve this problem. How it is, I'm going to explain. Right? So I'm going to explain. Everyone listen. So I took one graph. Remember, it is an undirected graph. We have to identify cycle. In the given undirected graph, how to find out cycle, that is the purpose of this problem. Using DFT, we can do it. How? I'm going to do this. Right? What you do is take one visited array. Take one visited array. So let me take one visited array. How many people are there? 4 plus 4, 8, 9 vertices. Total 9 vertices. Let me explain now. 4, 4 and 9. 4 here, 4 here, 9. So let's see this one. A here, B here, C here, D here, E here, F, G, H, I. All people. Visited of every person is initially 0. Not visited. Initially everyone is not visited. Now how I am going to do? Please listen properly. Please listen properly. So I started algorithm from A. See this one. DFT algorithm. I started from A. DFT algorithm, I started from A. Listen carefully. DFT algorithm started from A. So current vertex is A. Visited array, it is a global array. Global array, no problem. And one more thing is, right? DFT algorithm, I started from A. And I have to say, what is the A previous? Let us assume that A previous, starting node previous is -1. Previous is initially -1. Right? Previous is initially -1. Assume. Right? Current vertex is A. His previous is -1. Right? Observe properly. Observe properly. Right? So P is as of now -1. Initially, P is from outside. It is a -1. Right? Now see. First step. See the first step? See the first step. Widget of A is equal to 1. Okay. Widget of A is equal to 1. And previous is -1, that is absolutely fine. Previous is -1, that is absolutely fine. Next one, what you do is, what the DFT algorithm will do is, A adjacent find out, take one person. So C. So A adjacent is actually B also, C also. A adjacent is actually B also, C also, but DFT will take one of the person. So it will take C, do the same story. It will take C, DFT algorithm you will do. So this one, DFT algorithm. Current vertex is C and is previous, remember, previous is, I think the previous one is, I think this one, A. It is A. So every person required, what is the previous? So current vertex is going to be C, previous is A. Right? Same story. What is the first step? C will be visited. Now same story. What is the answer? C adjacent to find out. C adjacent is going to be A also, D also, E also. Take one of the person. Take one of the person, but remember, right? That person cannot be previous. So remember, C previous is A. So C adjacent is A also, D also, E also. But C adjacent is A, which is previous. Don't take. Don't take it. That is the only reason why I am passing previous. And every person having his own previous, right? They are not common. So A previous is -1 because starting. So now see this one. C previous is A. Right? Now see what the answer. So I am at C now. C adjacent is A, D, E, but A is previous, don't take. D and E, anyone you can take. So I am taking the E. I am taking the E. So DFT apply, DFT apply, right? By going E. So you came here. But previous, if you observe, if you see the E previous, C. Again DFT. So what is the answer? E visited. E visited. Alright, next one. After visiting E over, next one what you do is E adjacent people find out. Which are not visited. Which are not visited. See, E adjacent which are not visited. E adjacent which are not visited. So then what is the answer? E adjacent is going to be H also, F also. E adjacent is H also, F also. But you may say that C also. But you cannot take previous. You cannot take previous. So E adjacent is going to be F and H. So I will take H. So what is the answer now? So DFT I will apply. Right? DFT I will apply on H. And previous one if you observe E. Previous one if you observe E. Same story going on. What is the answer? H will be visited. Within a few minutes you will get the clarity. H will be visited. Next what is the answer? So lack of space I am adjusting here. It is a recursive program. Everywhere doing same story. So what is the answer? H adjacent to find out. H adjacent to find out. Right? Adjacent you cannot take which is previous. Right? Which is exactly previous. H adjacent E don't take. So remaining things I and F. So take the right DFT algorithm call by taking I previous is H. So once again call the DFT story. I is visited. I is visited. I think I is visited. That is fine. Next one is going to be I adjacent what? Which are not visited. I adjacent what? Which are not visited. I think all are over. That means, listen, that means this is completed. Popped out. So you will go to previous. Can you help? Previously H. H adjacent is what? I also, F also. I completed, now F. Right? Now F. So that's the meaning of backtracking. So you came back because of no option. Now it will call F. So lack of space, I am going here. F. DFT call on F. But F previous. What is the F previous? So careful everyone. F previous what? Previous is from where you came. F previous is going to be H. H you came. Now again same. What is the answer? F is visited of F is 1. Now visited of F is 1. Okay. Who is the F adjacent? F adjacent is E, which is already visited. F adjacent is H, which is already visited. You know very well. The things which are already visited, you don't need to visit. Right? Next one. I think F adjacent is G. So I think G will be called. DFT G called. What is his previous? G previous is what? F. Right? Again same. G visited. G visited. Right? Next one. After G visited, everyone observe now. So I think you went here. Because of backtracking, you came back. You went here. You went here. You are currently status here. Now I am at G now. G already visited. Can I help? Now who is the G adjacent which are not visited? I think D. So DFT, D called. D previous is G. So D visited. Now who is the D adjacent which are not completed? I think B. So B called. DFT of B called. What is the B previous? D. So same story. What is the answer? So B is visited. Now you will see the interesting story. B is visited. Okay, fine. B is visited. It's okay, fine. Next one. Can you help me? Who is the B adjacent? Who is the B adjacent? I want answer from all of you. Who is the B adjacent? B adjacent is this one. B adjacent is A. B adjacent is A, which is not previous. I am at B now. B adjacent what? D also, A also. Right? Both are adjacent, but interesting is B previous is D. But B previous is not A but visited. This means cycle. Means what is the meaning? You have to come in some other path. You came to the old one by same edge. See, you went like this, you came. It is not a cycle. You came to the old one by different path. Means B previous is not A, but is the old one, but it is not a previous one. This indication that here cycle is happening. Here cycle is happening. So cycle happened here. What I mean to say is, if you visit the old person, it doesn't mean that cycle. Old person which is not previous, that is a cycle. That is the reason everywhere I am managing previous. Everywhere I am managing previous. What is my previous? So I am going to the old one which is not previous. Then it is a cycle. So I written the code also. Roughly I written the code also. You can see this. If you want, you can see, right? One more example also here. One more example also here. See this one. You can see one more example also here. A here, B here, C here, D here, E here, F here. Remember, old one if you visit, it is not a cycle. Old one which is not previous, then it is a cycle. Then it is a cycle. So I will explain here. I am at here. Visited. Visited of A is 1. But remember, visited of A is 1. A previous is minus 1. A previous is minus 1. Adjacent people take one person and go there. I am at here. So B also visited. But B previous, remember A. Right? B previous, remember A. In the similar way, B people adjacent which are not visited. So I will go here. Is not visited, I went there. So C also visited. But C previous is B. Careful. These are previous. These are previous. Every person having previous. Right? First person previous is minus 1. Next one. I am at C now. So C adjacent which are not visited. This person I will go. Because visited of this person is not 1 as of now. Is not visited, so I came. So now visited of D. Visited of D is equal to 1. Now only visited. What is the D previous? C. Right? I came to here. Again E also not visited. Visited of E is equal to 1. What is the E previous? E previous D. Right? Fine. Now I think E adjacent people, I think this person is not visited. So F visited is 1. But F previous is E. Now observe. Now observe everyone. Now observe everyone. Now observe everyone. I am at F now. Who is the F adjacent? Who is the F adjacent? I want answer from you. F adjacent is B, which is already visited because F is already 1. See, sorry. F adjacent is B, which is already visited. Okay, old person. F adjacent is B, which is already visited. But interesting thing is F previous is not B. Means what does it mean? You came in some other path. But one more interesting thing is F adjacent is E, which is already visited, but it is a previous. Means no cycle. F adjacent is B, which is already visited, but not previous. But not previous. That means this is leads to cycle, which is also called back edge. Normally it is called back edge. This terminology, instead of saying big story, they just given simple name back edge. So while doing a DFT algorithm, if you find out back edge, so cycle exists. Cycle exists. You have to compare the previous person. Other than this, nothing there. Compare the previous person. I think I written the code also. See the code, rough code I give him. I try to give some pseudo code, not some programming language code, some pseudo code. Right? Let's see this one. See this one. So here I call the cyclic function. Cyclic or cycle, whatever it is. I call the cyclic function. If it is true, cycle is there. Otherwise, no cycle. So what this function will do, let's see here. It is actually cyclic. So what this function will do is, all vertices he will keep visited as initially 0. Now he will take one of the vertex. Right? In all the vertices, one of the vertex he will take and he will start doing. Widgeted of that vertex is false or not, you will check. If not widgeted, then only widget. Widgeted of that vertex is false, yes. Then call DFS algorithm. Right? See this one. I call DFS algorithm, some name I given. I call DFS algorithm. I pass with that vertex. Widgeted array also I am passing. And parent as of now, -1. I am calling this function, DFT algorithm I am calling. Right? That vertex I am passing. Which vertex? If A is A, I is I. So maybe A passing, and A initial right? A vertex previous is -1. I am passing. It is a recursive program. Right? It will go here. It will go here. Let's see what it will get. A came. Widgeted array is came. It's okay. Parent is -1. As soon as you came inside first one, widgeted of A is true. Widgeted of A is true. Afterwards, after it became true, now what you will do is this one. Now, for the A, who is adjacent, find out. A adjacent, all find out. Let us assume that B. Now check, widgeted of B is equal to false or not. If not widgeted, then all I will widget. Yes, false means not widgeted. Then call recursion. But remember, right? Remember here. So parent place you are passing. Parent place you are passing V. What is a V? A. You are passing A. Previous parent is -1. Now parent is A. Next parent B. Like that, it is keep on updating. It's keep on updating. Some point of time, what happened is widgeted of I is equal to false. If false, you will call recursion. It is fail. It is fail means widgeted. This is fail means widgeted. So if it is widgeted, come here. Then check parent, right? Parent not equal to I. Parent is not I check. It is already widgeted, right? Parent is the previous one. Parent is the previous one. For the I, right? See this one. I think what is the current person? I. Current person is I. Parent not equal to I. If it is equal, not equal to I. If it is equal, false. Right? See this one. Parent not equal to I. Then return true. Whenever you saw the previous person, parent is not equal. Parent is not equal to previous one. Right? See this one. I think what is the parent? Just I want to ask you one thing to you. What is the parent? Let us assume that right? Let us assume that parent is A. I is B. See, I is B. I is B. Parent is A. So A not equal to B. Just check both. They both are not same. Right? If they both are not same, true. Cycle happened. If they both are same, so I think cycle not there. Something like that. Same story, whatever I explained, same thing happened here. Check properly. Right? Whatever condition I verified. So go to the previous one and verify here also. See, I am at here B. I am at F here. What is F previous? F previous is P. F previous is P. So what I am doing is, right, F parent. Right? F parent is E. F parent is E. E not equal to this I. That's what you want to say that. That's what you want to say that. So cycle exists. So like this. Same whatever I explained, just execute properly, you will get the clarity. Right? Fine. I hope everyone is fine. It is exactly DFT. It is exactly DFT. So time complexity V plus E if it is a list. If it is a list, time complexity is V plus E. If it is a matrix, matrix V square. Adjacency matrix V square. I hope you got it.